Hello everyone, welcome to Visionary Classes. Today we will start with the lecture number 8, that is from the part B section of the CUCET exam. So you guys subscribe our channel and contact us for the latest study material on this number. Let's start. So the first question that we are dealing with here is from the EVS section. The question tells radiocarbon dating method is used for the material found in how many years. These are the options. Okay, so before answering this question you should know what is radiocarbon dating. Okay, so radiocarbon dating is also simply called as carbon 14 dating. Carbon 14 is a radioisotope of the carbon, okay, with a half-life of 5730 years. So the answer will be definitely 50,000 years, okay, which is very short compared to above isotopes, okay. That's why this is a radiocarbon dating with less than 50,000 years. The second question tells the first land plant appeared in which of these geological ages? These are the geological ages. So the answer will be Ordovician. The definitions behind this is the first land plants appeared in the 470 million years ago. Okay, so during the Ordovician period when life was diversifying rapidly. They were non-vascular plants like mosses, liverworts that did not have a deep roots. Okay, so these are very small plants. Okay, जिनके roots कम होते थे. ठीक है, तो ये plants हमारे ऑर्डोविशियन टाइम पे मिलते थे. So next question tells us that a flow which is a balance of a pressure gradient and a Coriolis force is called as. There are four options: gradient flow, geostrophic flow, inertial flow and Coriolis flow. Okay, let us discuss the answer. Okay, so the pressure gradient force, when it is exactly balanced with a Coriolis force, it gives rise to geostrophic current. Okay, that is a geostrophic flow. So the answer will be geostrophic flow. What does geostrophic flow means? The geostrophic flow is a theoretical wind that would result from an exact balance between the Coriolis force and the pressure gradient force. Okay, this condition is called as geostrophic equilibrium or geostrophic balance. So the answer will be geostrophic flow. This question tells ocean boundary currents are: warm, slow, narrow in both the hemisphere, warm in northern hemisphere but cold in the southern hemisphere, cold, fast, shallow current, warm, fast, narrow currents in both the hemisphere. So the answer will be warm, fast, narrow currents in both the hemisphere. Let us discuss the concept. Okay, western boundary currents are warm, deep, narrow and fast flowing current that forms on the west side of ocean basin. Due to western intensification, they carry the warm water from the tropics poleward. That's why this happens. Example, the Gulf Stream, Agulhas current and Horatio current. Okay, these are the examples of the western boundary warm currents. Okay, so what does western intensification means? The western intensification applies to the western arm of an ocean current, particularly a large gyre in such basin forms. Okay, the trade winds blow westward in the tropics, the westerlies blow eastward in at the mid latitude. Let us see this all concepts in the map. So this is the map. Here you can see this is Horatio current, this is the East Australian current, this is the Brazilian current, this is the Gulf Stream and North Equatorial current, this is the North Equatorial current, Agulhas current, these are the currents. You can see all the western boundary of the ocean. Okay, this is the ocean part. Okay, this is the western boundary. You can see these all western boundary currents are warm in nature. Okay, and as well as they are fast moving current in our globe. Okay, so you can see, so this is the answer, that these warm currents are very narrow, fast, and are shallow in nature. So this question asks about the El Nino. Okay, what is El Nino? Okay, let us discuss first. So during a normal year, okay, what happens? Our warm water current was seen in the Australian coast. Okay, there is a equatorial wind gather in the warm water during the our normal years. Okay, but at the same time, you can see there is a cold water in the eastern part of the Pacific Ocean. But in the El Nino year, you can see the easterly wind weakens, the warm water moves towards the South America portion, that is the Eastern Pacific, okay, and it will give rise to their low productive zone during the El Nino years, okay, and there is a drought condition found in the Australian region because the warm water moves, and we know that the warm water have warm air above it which will rise and it will cause the rainfall. But at the same time, if there is no warm water in the Australian coast, it will decrease the rainfall and it will bring the drought condition. So this is very harmful phenomena that happens in the Pacific Ocean for both the continents, Australia as well as the South America portion. The next question is on the monsoon. Okay, so in the India Ocean, South equatorial currents crosses the equator during which? This is the question. The answers are spring, southwest monsoon, northeast monsoon, western disturbance. These are the options given. The answer will be southwest monsoon. Why? Because during the southwest monsoon, the winds that are coming from the Australia, okay, as well as the wind that are flowing in the equator, okay, southern part of the equator, it will reverse, because monsoon is a reversal wind. Okay, this happens during the month of May to June. The reversal of this equatorial wind happens in the month of May and June, and it will reach to India. So this is the map. So the answer will be southwest monsoon, because during this time the southern hemisphere equatorial current crosses and comes to India. So what happens during the northeast monsoon? During the northeast monsoon, the monsoon wind retreats. Okay, it passes towards the Kerala coast and moves away from the our Indian subcontinent region. This is the northeast monsoon. Okay, the northeast monsoon derives its name from the direction in which it travels. It travels from northeast to southwest region. While the western disturbances started at the Mediterranean high, and it moves towards the our Indian northern region. Okay, this is the western disturbance. Okay, so the answer will be the southwest monsoon. The next question asks, which are the major nutrient which limits the phytoplankton growth in a marine environment? As we know, the phytoplankton requires the food chain in ocean water starts from the unicellular algae. Okay, so unicellular algae are the biomass unit that starts the our food chain. Okay, so the phytoplankton requires iron, nitrogen, phosphorus and silica. These are the nutrients that is required by the marine phytoplankton. So a phytoplankton feeds on the mineral elements such as nitrogen and phosphorus and iron, which they convert to light energy into organic material by the process of photosynthesis. This is the function of the phytoplankton. Any shortage of mineral elements will decrease the photosynthesis, hence the algal biomass produced. This is the concept. Okay, but the question asks about the limit the phytoplankton growth. So if you limit the nutrient of the phytoplankton, then it will limit the phytoplankton growth as well. So the limiting nutrients for the growth of a phytoplankton are the nitrate and phosphates. So the answer will be nitrate and phosphate. I hope you understand the lecture. Have a nice day.